So guys, welcome to my YouTube channel. This is Tech with Kevin. In the previous videos I taught you how to do data cleaning and then data analysis, but in today's video we are going to learn how to interpret data, then to come up with a PowerPoint. And the next videos to come we shall also learn how we can write professional reports after doing the output. So we can use the sniffing tool whereby we can screen record or capture the screenshots and then we add them in our PowerPoint, or simply we can just get the output and then save it as a Word document, and then we just use the Word document to just copy and paste in our PowerPoint. So in this video I'm not here to teach you how to write PowerPoint because I believe you already know. I'm here in order for you to help you understand and then develop a really responsive and professional PowerPoint. So let us dive into the video. So ladies and gentlemen, welcome back to my YouTube channel, that is Tech with Kevin. As I told you, if you want to transfer data into a PowerPoint, so one method, you can just right click on this table and and select copy, then you come here in your PowerPoint and then you paste. So when it comes like this, give it a reasonable size so we can reduce on the size of the table. Then try to, so you see how our data is looking like. So we try to organize, leave reasonable space, whatever, but the best way is for you, when you come here, just use the sniffing tool. Let me search sniffing tool. Enter. So just place new, select new, come here and select new, then just copy paste. Copy, come here and then Ctrl Z on Ctrl Z, then Ctrl V. Wow, this is better than the previous one. So I'm not here to teach you that, but that was a way out. Then another thing I can add on, let us go back to our output. You can just remove this as a word, export. So let me put it on a desktop. You see here, save type as a word. Let me just name as my output. I don't want you people to cram. Let me save it as for the presentation. Okay, then save. So meaning that if I go on my desktop, I will find it. So we're analyzing the academic and demographic determinants of all-level students using their PLE result. Of course, our presentation outline. Here we are looking at the introduction and a program statement, and then objective and hypothesis, research question methodology, descriptive statistics, correlation results, regression analysis, chi-square test, discussion, and then we did conclusion and recommendation. So in our introduction, of course, our project title was Academic and Demographic Determinants of O-Level Student Performance in a Selected Ugandan School using based on their PLE results, as I told you at the beginning of the slide. So we began by defining the meaning of the PLE result as the assessment given to students in primary towards them going to their secondary school. And then we had the so-called performance impact, that the performance determines admission to the top tier. In other words, if there is high performance, what happens? Students are likely to get better schools, they are likely to get government sponsorship. Then the need for research was to understand the factors influencing the PLE outcomes. Why is it essential to fairness and student support? Then our program statement, of course, we had the knowledge gap, that of course there was lack of ethical research linking student demographics here. When we talk about student demographics here, we mean gender, age, nationality, stream, with the PLE subject scores in a Ugandan private school. So the need for the policy, need of course educators and policy makers need data driven insights to identify a risk students and design a targeted integration. So we had a case study we are dealing with, which had 742 students. Of course, this was the record after removing the outliers. So we used the software which we learned together, that is the IBM SPSS statistics. Then the objectives of this research was to examine the relationship between, I told you how to examine relationship between different variables. Then our specific objective was to describe student demographics and academic characteristics, and then identify trends, then outliers. So when we talk about outliers here, we mean extreme values which goes beyond the normal distribution. Such variables can distort or change the value or our intended figures of the mean and standard deviation. For instance, if we have a score of the range which is moving from for instance 1, 2, 3, 4 and 5, all of the sudden I get 20, so that 20 becomes an outlier. Or when we have the age, that we are dealing with the age which is around 20 years, then all of the sudden I see a person who is having the age of 2, that becomes a mild outlier. So another one was to examine the relationship between demographics and academic outcomes, then determine whether individual PLE students predict the total performance. So we came up with our research question, that is what is the mean, median and standard deviation of the PLE subject scores? Is there a significant difference in the PLE aggregates by gender? Is there an association between student, stream and nationality? How strongly are the PLE English and mathematics correlate? Can total PLE score be predicted from the English, math, SST and science? Then we came up with the hypothesis. So we came up with the methodology, of course. That was the design sample size, then data source, and then the analysis tools. Then we had the descriptive statistics. So what I told you is that you can just copy paste the so-called you can just copy paste the table, or you re-edit it. Or what you can do, you can use the sniffing tool, yeah, and then you copy and just paste. But for me, what I did is re-editing the descriptive statistics summary, yeah. So next we came up with an histogram. Remember I told you that histogram used the histogram when dealing with continuous variables. Then when dealing with categorical variables, you come up with the bar graph, or you can use a pie chart. So I don't remember teaching you outliers. So what I told you, so outliers, I told you that those are extreme numbers. Yeah, so if we have here a simple box plot for the PLE total by gender, so here it shows cases labeled 560, 340, 341, and then 36. So they are just sun-code. Do you know the meaning of this? If they are sun-coded, it means that the outliers, they are not that extreme. But if they are extreme, they will be represented by a star. So meaning that female and male, when we see their performance, it was ranging from around 4, and then yeah, of course should be 4 for aggregates, and what, 25. So in figure 3 we see the PLE aggregates after removing all the outliers, and then figure 2 it shows gender and their ages. So here it shows that a box plot showing scale data on categorical variables after removing the outliers. That is what summarizes that. Then we did patterns, trends, and outliers. Of course, I've talked about the outliers. So here the key findings and from descriptive and visual analysis. So here we had age and performance, and then we say that we had a slight positive trend was observed as older students tended to achieve higher total PLE aggregates. Yeah, so the correlation was statistically significant since our p-value was less than 0.001. So the R represents the correlation coefficient, which is 0.118. So our N, our sample space from the age, it was 1,586, meaning that we removed the outliers because we realized that we got some samples. So we got some samples where we realized that some ages were computed as one year, which was impossible. So one thing we should also put in mind is that we should put in mind that in SPSS we should try as much as possible to remove personal information of individuals, such as names, registration numbers, ID, location. Such things are not included in data analysis. So this is what I told you about the Pearson, where the one comes from. It's like saying we are getting the correlation of age and age. That is where the one comes from. So age and age, they can't give you a significant test levels, but if we have age and PLE totals, so here we see our correlation coefficient, which we talked about as our which is 0.118, and then this data is significant since our correlation coefficient is less than the 0.001, and then we see the N, which is the sample size, and then that level. So meaning this data is significant. So this is the correlation results. Yeah, they still talk about the same things. I'm not going to talk about that. And then here, in order for us to deal with visualizing this, you can use a scatter diagram. So this is a simple scatter diagram showing the PLE science by mathematics. Actually, what happens if a point in mathematics is increased by 1 point, what happens to PLE science? PLE science also reduces, meaning that as students tended to pass well or to do well in mathematics, what happens to the scores of their science? The scores of their science reduced, meaning that students, we should, in order for us to find ways to increase their science subject, we should, you see what happens. We should balance them. We should balance that. If a performance in mathematics increases, what happens to the science? Also science increases. That is what we want. So like here we see here that age as older student tended to have higher marks or greater. In other words, if a point in age years increases, what happens to the PLE aggregates? The PLE aggregates increases. So let me try to explain the R squared. The R squared represents that 1.6% of the variance of the PLE science, it is explained by the PLE mathematics. The same here, that 1.4% of the variance of the PLE aggregates, it is explained by the age. Okay, so those are at our lines of best fit. So let me try to explain here. So this is just a scatter plot matrix. So here we have PLE English and PLE English. That's why this place is blank. But yeah, just know that this matrix plot just summarizes everything. That if we have here PLE totals and PLE English, it is represented here. PLE science and PLE mathematics, they are represented here. If I want to get PLE science and PLE mathematics, this is the one. PLE science and PLE SST, that is the one. So the chi-square test, that is that. Okay. The degree of freedom, just I told you that those are just the number of variables, and then we have got the significance levels, which we tested that this whatever, they are not related or they are not significant. So we did some cross tabs. These cross tabs, they are just representing this. Actually, you should add everything you know or everything you have analyzed in SPSS, as long as it is of some importance. Add everything. Graph. So here we wanted to see if there is a difference between the performance of male and female, but we realized that the confidence interval, all variables, the males and the female, they were within the range. That is why we had to conclude by saying that there is no difference between the performance of male and female. So we had to reject the null hypothesis. Okay, so let me show you here the graph. You see here that there was a range of 5 and 15. Of course, there was no what else should we talk about? Did I talk to you about regression analysis? Okay, we did some regression analysis. Yeah, we should be knowing everything where we talked about our R as our correlation coefficient, which is a weak positive correlation, and then the 1.4% of the variance being explained, and then here we see that that we have got the predictor, we have got the depending variables and the what, and a predictor, yeah, meaning that our predictor is going to be on the x-axis and our depending variable is going to be on the y-axis. So here we see our degree of freedom as 1 because we have one predictor. So we see that there is significance level since our significance variables are less than the threshold of 0.001. Okay. Here we had the conclusion that interpretation age is significantly significant, but explains only 1.4% of the POE variance. This is not a meaningful predictor, so meaning that 98% of the variance is due to other factors. We should be knowing everything. So this was our highlights. I think that is that. We had some recommendation that monitor older students, then maintain a balanced gender enrollment, and then for future research conduct school whatever, include socio-economic variables. We did that. So ladies and gentlemen, thank you for being part of my YouTube channel. So in the next video I'll teach you how to do a standard report. Actually, I'm not going to teach you everything, but I believe that you already have some ideas, so I'm going to build on what